Hi all, welcome to the second episode of Architectural Strategies in Cloud with myself Vishnu Viji. This is Coding Talks. I'm a .NET programmer from Thiruvananthapuram, Kerala state. I have experience working with different cloud technologies like Microsoft Azure, Amazon Web Services and Google Cloud. In addition to that, I am an AWS community builder as well. I do have a podcast as well as an YouTube channel. So that is of the same name, Coding Talks with Vishnu. So feel free to check it out. So this is a continuation of the previous episode related to the architectural strategies in cloud. In case if you haven't listened that episode, I strongly recommend you to listen that episode, which is available on my podcast. The podcast is available on all platforms, including Spotify, Apple Podcast, and others. So feel free to listen from any of your favorite podcast platforms as you like. Before starting this episode, just a quick recap of what all we have learned in the previous episode. In the past episode, we have understood about some of the basic patterns like the layered or the tiered architecture. We generally call it as n-tier architecture. Some people will prefer to call as three-tier architecture or two-tier architecture in general. Many of you may already have experience working with that. We understood how we can leverage that in the cloud. Then we also understood about the multi-tenant application, where a same application can be served to different customers with its own isolation. We also understood about the service-oriented architecture and how various approaches, including stateless caching and other other methods can be used on these basic patterns to improve its functionality. While explaining those, we understood in terms of some of the AWS services like the storage, AWS CloudFront, EC2 instance, elastic load balancer and so on. So in case if you like to listen about all those in very detail, I highly recommend to listen that episode to get an overview. Today we continue our journey into the architecture by looking into the recent trendy patterns like the microservices patterns and the serverless pattern. In the previous episode, we understood that we can develop applications using the layered architecture or the entire architecture as well as the different ways using the service-oriented architecture. But that same applications can be developed for the cloud, optimized for the cloud using the microservices or serverless architecture as well. So when it comes to microservice, most commonly suitable word for the deployment models is the container and the serverless mode of deployment. So when we develop a microservice architecture, we can either deploy that as through a serverless model or through a kind of a container based approach. If you plan to deploy that as serverless, you need to consider that at the initial stage. Similarly, if you want to deploy the microservices as container, you need to consider that at the initial stage. Both offers its own perspective, its own advantages and its own challenges. We will think about all those as we go through the episode. First, we understood about what is microservices, and then we can understand about deploying the microservices in terms of serverless as well as container concepts. We can also understand how different AWS services can help to deploy these services in a better fashion. When I say deployment, it needs to be think in advance. Like whenever we plan a microservices application at its design stage itself, we need to think about whether we want to deploy that as a microservice or in a serverless fashion. Like I said before, each has its own challenges and its own benefits. We can look on what all are some of the challenges and some of the benefits that offered by these different models. Before that, we can understand about what is a microservice architecture. So microservice architecture is very easy to understand. Previous episode, we understood about the service-oriented architecture where a monolithic application can be split into different components, and each component provides its own functionality, and it can work independently of each other. And these components will interact with each other through a common protocol. That protocol can be either a SOAP protocol or a REST API. So you're further moving from there, from the service oriented architecture to a microservice architecture, where you actually more modularly split the monolithic applications into more modular services, where each services work independently and communicate through a communication protocol. Mostly, majority of the application, microservices application, if you look, you could see the REST API. And the advantage, one of the advantage of microservice kind model of application development is each services can be scaled independently without affecting rest of the services. Each services that are developed in microservices has a smaller surface area, so the teams can develop these individual services within themselves by smaller teams. They have to think about how their application or their service works effectively, and they need to think about some of the things like how other when some other service returns a data, how our service should work and all those things. But generally they can focus more on their own individual service. So that is the modularity that a microservice architecture is providing to the developers. So in an organization, there may be experts working with the different technologies. So a team can be formed, and maybe the front end can be developed using some JavaScript frameworks like React or Angular. And there may be experts that are proficient in those technologies. They can work in that. Similar way, the backend related services can be work in some other languages like C# or Python. Similar way, in the microservice architecture, a monolithic application can be split into different service areas, or we can set the boundaries. And these boundaries work in isolation, but they communicate with each other. And the teams can independently develop them. So they can choose which technology best suitable for their part, and they can work more effectively. Another important consideration that an architect must consider when designing a microservice architecture is fault tolerance. Fault tolerance is an important factor. This means that there may be multiple services work in isolation but communicating each other to make the entire application work in a smooth fashion. But sometimes if one service goes down, the architect should design the application in such a way so that it should degrade gracefully without any cascading failures. That means if there are multiple services, and if one service fails, it should not result in a failure on other service. The other service should continue working, and when the initial service that got failed, when it comes back to the normal state, it should co-work with the other service. So that way, fault tolerance is an important factor to consider when developing the microservice architecture. So each service should run on its own. Each service should not directly depend on other service, and that way it should run. And whenever some fault happens to one service, it should not affect the other service. And another important thing that you could consider when developing microservices application is to create a separate data store for each service. There may be 5 different microservices for an application that is architected using the microservice architecture. And you can have a separate data store for each service, but that also depends upon the type of application that you want to develop. Sometimes a separate data store for each service would be an overkill. So most of the times architects prefer to choose a single data store and share it between these services. But there is a suggestion that we can heard from the architects that if you see a possibility for each service to scale independently, then it would be better to keep a separate data store for each service, so that each teams that are focusing on that modular service can choose a best data store and they can tweak according to their preference. The main goal is each teams wants to provide the best output and performance from their service which they are related to. Together, that can bring an overall best performance and output from the entire application, and that will lead to a better client experience. Another thing is to consider when developing the microservice architecture is to build the microservices as stateless way without storing any state in its servers. In the previous episode, we have understood about the importance of stateless, especially when dealing with a shopping site like Amazon. In Amazon Web Services, in Amazon shopping site, you can log into the Amazon from a laptop. You can select a product. You can search and select a product, and you can add that to wish list. You can even check out that product, and you can complete the checkout from a different mobile device as well. So this means that your user state is not tied to a particular server or server instance. So multiple servers will be working behind the scene, just like we understood yesterday from the when we understood about that EC2 instances working in parallelly behind a load balancer. Similar way, the user session is not tied to a particular server, and it is stored entirely separate in a NoSQL database like the DynamoDB. So that way, the application can work in a stateless fashion. So that same consideration you can apply here when develop the microservice architecture also, because when you are storing no state on the server, your application can effectively scale up and down without bothering about the server state instance. So including that with the microservices when developing the microservices will provide a better and seamless experience for the user. So you can consider that as well along with the data store, individual data store like I mentioned previous. Then the other thing to consider is how we plan to build and deploy the microservice architecture. So there are different approaches there. In the beginning of the episode, I mentioned about the container deployment pattern as well as the serverless pattern. So you can choose either one of them. There are other ways also, but these ways will be more suitable in the modern cloud day architecture. So container pattern, we can think about that first, and then we can later think into serverless pattern. So there may be arguments in favor of container patterns as well as for serverless pattern, but the recent trends shows that serverless is a buzzing word, and it provides the best user experience, as well as it provides the most cost effective and scalable strategy that we can adopt in a cloud environment. There is a disadvantage as well when it comes to the developing serverless application that we can discuss later. First, we can look into understanding about the container pattern. So we have a microservice architecture in hand. We plan to develop a microservice architecture. We understood that we can have different services. Like, for example, for the sake of understanding, we can select a payment application or a shopping application where we have the different services, like a service to show the list of products, then maybe another service to check out the service, and another service to make payments to the shopping site, and maybe an entirely another service to display and capture the list of reviews. So different services are out there. So when we consider the entire shopping application, these services should work in parallel, isolately but in parallel, to provide a better experience. So they may be communicating with each other through mostly the REST protocol, and each service must be fault tolerant, that must be stateless, and each may have ideally its own data store as well. So now we want to deploy these services to the server or some cloud environment. So container pattern is one pattern where you can individually package your individual services as containers. It's similar to the shipping containers. So in the case of containerizing of application or services, it wraps up all the associated libraries, dependencies that are part of the service, and you can deploy it as container. The benefit that it provides to you as an application developer is you can wrap up all the dependencies, libraries in a standard way, and you can deploy that for the containers in a standard way, so that you can ensure that independently of wherever it is getting deployed, it should work, because everything that needs for working of that particular service is binded to that container. So that container has everything, and you not need to bother about the associated where it is getting deployed and what all dependency there we need to have and all. In the olden days, we should bother about where we want to deploy our application. If we want to deploy a website to a server, we need to think about what all dependencies are required for that services to run and work effectively. But in the case of the containerizing of application, whenever you package your application, you ensure that all the associated DLLs, associated dependencies and everything are correlated there. And maybe that service will have some external dependencies like API or some other services. So that all also included as part of the part of that architecture inside the service. So that service can itself communicate with an external API or something, and all the other libraries and everything that are related to running of that particular service will be shipped inside that container itself. So that container is a package, and you can provide it to any of the cloud service. So Amazon offers some of the cloud services that are particularly optimized for containers. We can look into some of the container services that are provided by Amazon. Similar way, other cloud vendors also provide. So once you have a shipping container in place, you can store that inside a registry. And each time when you change an service, you can create a new build. And that way you can deploy it independently of other service. This means if your application has 5 individual modular services, 5 services can be deployed as individual shipping containers with its own dependencies and everything. And whenever there is a change required in one of the service, you can deploy that, you can modify and deploy that service without affecting any of the other service at all. So this way, it provides a more seamless consistent deployment model without affecting any of the other, or can we say like a fast deployment model where feature that you are visualizing is moving to production in a more faster way. One of the best service that we could see from the Amazon is the Amazon Kubernetes service. So that is the Amazon Elastic Kubernetes service, or we call it EKS. Similar way, Azure also has its own Kubernetes service called Azure Kubernetes Service, or AKS. So this is a managed service where you provide the shipped container package, and you ideally store that it inside a container registry, and you provide other details to these kind of services like the Amazon Kubernetes service, Elastic Kubernetes service. While you mention these package to deploy to the Kubernetes service, you also need to mention how much instance you want and everything, how much capacity you need and all. So rest of the things, this Kubernetes managed service will manage automatically. So it's kind of an orchestration built on top of Kubernetes service. So Kubernetes is another orchestration service from Google. So these cloud providers adopted these Kubernetes service and on top integrated on top of their own cloud versions. So Azure has Azure Kubernetes service, while the Amazon has Elastic Kubernetes service, which has its own unique peculiar features that are branded according to the different cloud vendors. But commonality underlying the Kubernetes service is what working. The input we are providing to the Kubernetes service is the packed container which we developed for our microservice architecture. In the simple case, if you understand about Kubernetes service model of deployment, we can say for a simple microservice website, it may have a front end and a back end. So front end may be in a React language it is developed, and the backend may be developed using something like a web API or a Node.js. So you can have two containers, and two containers can be deployed to the Amazon Kubernetes service. So whenever you deploy, you mention to the service like, I want this much of instances, and accordingly it will automatically scale the instances whenever it is getting deployed. The another on benefit that these managed service provides, like the Kubernetes, is the provision to auto scale and scale down the pod instances. So sometimes you have a peak load where you want to upscale your front end or back end instances, where from maybe 2 pods to 3 pods or something like that. These Kubernetes services can do on behalf of you, behalf of the application configuration, and it automatically scales up and down based on the kind of usage. And sometimes there is a chance that some of the pods may crash either because of the memory problem or like that. In that case, it will automatically, this Kubernetes service will automatically recover those instances as well. So some of the things which the tops needs to do manually will be handled automatically by the Kubernetes service. And the main advantage that I felt from this kind of application architecture is the way by which it is wrapped, so that all the associated dependencies that are required for the service can be wrapped there itself. So you don't need to bother anything about some of the other matters at all. So this greatly solves the problem of dependencies, where if some dependency goes missing on the target deployment area, application breaks. But that won't happen in the case of the containerized application, because everything that is required for running the application will be shipped inside the container. So this model of deployment is best suited. One example I could say about this is, recently I have made a .NET Core application, which is a simple exe, and I have, it's a kind of a POC, and I sent to one of my friend. And when he ran this application, he don't had the .NET Core runtime installed in his machine. So when he ran it got a runtime error, and an exception was raised. This happened because the runtime environment was not there in his system. So this is just on dependencies. So similar way, for our application to work, there may be lot of dependencies. Some of the dependencies can be restored either from the NuGet or other package management service. But sometimes other dependencies like the operating system level dependencies and other dependencies are there, which will be sorted out by the at the time of the containerization of application itself. So in the .NET it happens like this. You ideally open the Visual Studio and you can select a type of project that you want. So whenever you create a project, Visual Studio nowadays offer the possibility for creating a containerized application. So you can enable the tick like run this application inside a container. So when you enable that tick, automatically a container or a Docker file will be added automatically to your application. So this means that your application is now container ready. Rest, the thing you need to do is to build the associate pipelines and other things which you want to deploy on the container services. So at the time of the building of application, the build steps that you are associated with will automatically package the application based on the Docker file you define. So this Docker file has an associated base image, and based on that, the Docker image will be built, and it will automatically wrap your application along with that base image, and then it will make it a final container, and that container is the one which is actually stored inside a registry. So when you look into the Amazon website, Amazon AWS, Amazon Web Services website related to the container services, you can have a lot of options. So there are 3 different categories which you can see, that is the registry, orchestration and compute. So when I mentioned about the containerization of application at the build stage, once the build is completed, we want to store the final container image. We call it as image inside a registry. So if you just want to store that inside a registry, Amazon offers a registry called Amazon Elastic Container Registry. You can learn more about these different services from Amazon documentation. For the sake of the episode, I am just mentioning a brief overview of all these. You can learn it later from the documentation or from different videos that are available in the internet. First, we can understand about the Elastic Container Registry. So, Amazon Elastic Container Registry or ECR is a fully managed container registry that allows you to simply store and manage and deploy the container images. So, its role is basically store your container image. So, using a pipeline like the Azure DevOps or some form of pipeline, you can create a container package based on the Docker file that is also stored along with your application, and then you can finally create an image and can be stored inside the registry. So the second thing is like you can orchestrate your image. So you have the image stored in the registry, but that is not usable for the client. You need to deploy that. You can simply deploy that and can later orchestrate, but nowadays you ideally deploy that and orchestrate it. So for that, an orchestration service is there. So different orchestration services are out there. So one is called the Amazon Elastic Container Service. So this is a fully managed container orchestration service that provides the most secure, reliable and scalable way to run containerized application. So that is one orchestration service, Amazon Elastic Container Service. The second one is Amazon Elastic Kubernetes Service, which is what I commonly saw in majority of the enterprise application. Here in Amazon Elastic Kubernetes Service, it's a fully managed Kubernetes service that provides the similar to the ECS, like a most secure, reliable and scalable way, but it's run on top of Kubernetes, which is a engine provided by Google. Then there is also another orchestration service called the Red Hat OpenShift service on AWS. So that is also a fully managed application platform with a IDE as well, runtime, and it has built tools, CI/CD service mesh and all. So it's a different service. So most commonly Amazon Elastic Kubernetes Service or Azure Kubernetes Services is what I have seen. But there are organizations which uses the Red Hat OpenShift as well as the Amazon Elastic Container Service as well. So other than that, when there are a different category of services which provides by Amazon when it comes to for the kind of a compute purpose, like Amazon AWS Fargate, which is a serverless compute engine for containers. Also Amazon EC2, which allows you to run containers on a virtual machine with a full control over the configuration and scale. So these are different categories of service tweaked to serve different use of the customers. But basically, for your understanding, you can create a Docker ship package or a container package for your different microservices. So if you have a microservice with 5 different modular services, you can have 5 individual services, each wrapped and shipped and containerized and can be deployed on a container service, managed container orchestration service like Amazon Elastic Kubernetes Service. So rest of the things, EKS will automatically managed as part of what you have provided in the configuration. So it can handle the fault when some crash happens for a particular pod or something. It can automatically handle that. Similar way, the communication between different pods can also be handled inside that managed service. It can automatically do that for you. Then the next thing is like next thing to mention is like how you want to have logging for this kind of application. Usually, when you host your service or some application in the traditional environment, you ideally have a log in that server. But that is not the case with the Kubernetes services like the Kubernetes service, where the pod is actually creating at runtime or when it is actually getting deployed. There are chances that a pod may get destroyed, a new pod may spin up. So you don't have the provision to store anything inside the containers, and it's not suitable as well. Sometimes if you don't have a log mechanism apart independently from the container service, it will be challenging for you to understand what is happening inside the container. So whenever you develop a container based application, it will be better to have an associated logging mechanism also. So ideally you need to have something like CloudWatch or CloudTrail in the case of Amazon, as well as in the case of Azure you should have something like application insights or something that should be connected from your container services. So when an issue happens, it will be logged automatically inside the container, inside the application insights, where the operations team can look into the application insights to get an overview of what is happening behind the scene. They may not have the privilege to log into that system to get an overview of what is happening inside there. They should have something like a way to differently log that using something like application insights and all. Now, if you look at some of the customer stories that are available in the Amazon Web Services websites related to the containers services, you can see that some of the firms are mentioning like they benefit from this containerization of services, like they increased the speed of market of microservices from 3 months to 24 hours. They can easily develop and deploy the services with the help of these container services, and also by effectively designing and running the application, container application, they reduced cost also by 50%. So effectively designing the container application inside a microservice architecture will be helpful for scalability, resiliency as well as recovery. You can have a list of all the different customer stories that are available. Some of the customers are Samsung, Disney and all. So you can understand how the Elastic Kubernetes service or EKS helped them to deploy the application. So this is one way of deploying the application. And another benefit that provides from this kind of container based deployment is the provision for you to move to a different cloud. Some organizations adopt the strategy of multi-cloud, where a single application may be deployed to multiple clouds for the sake of high availability and other things. Sometimes they may also envision a future possibility to migrate to a different cloud as well. So they foreseen this in before developing the application. So in that case, container can greatly help, because you can move a container application to a different cloud vendor more easily than other kind of serverless or other things. Because in the case of when you use a serverless kind of strategy, you have a binding with a particular cloud vendor. You may be using some of their serverless tools or something, and when you move to a different cloud vendor, you need to modify much of the existing logic and all, because the different cloud vendor may be providing the different serverless service in a different way. So there may be alterations required when you migrate your application to a different cloud vendor. But when it comes to the container, you are ideally shipping the application as a container. So there may be only a pipeline change required for you from the part of you as a developer. So this way you can avoid the vendor locking more effectively with the help of a container application. But the disadvantage is that for the running of container and everything, a cost will be much higher than that of the serverless. And also there may be development effort to containerize the application and all. And for smaller applications, this containerization would be an overkill. Microservice architecture requires a bit careful thought on how you want to design your application. That needs to be think at a beginning stage. Sometimes as you progress, there may be changes that come. So you need to foresee all that in some of these things in advance when developing an application. And the different services that work together should be fault tolerant as well. It should communicate in an effective way, and there should be logging mechanism also associated with that. So for a smaller application, this would be an overkill. But for a larger application or an enterprise application, microservice would be certainly rewarding for you. So this is an overview of microservices architecture. Next, we can look into the serverless in detail. So hope you understand about the container application. So if you are new to container application, using the Visual Studio or similar tools, you can easily create a container application. Basically, it involves simply adding a Docker file. And then there is a rest of things that you needs to done, like a pipeline deployment and everything, and should choose a associated container service as well. That is the deployment part. But from the development part, creating something like a Docker file would do the half part of the development. Rest of the things will be similar. Then there are other considerations that you need to consider, like I mentioned earlier, like a careful splitting of services for a microservice architecture. Some thought needs to be there. It must be resilient. It should be working in parallel, independently, and it should be lightweight as well. And each service should focus on a particular task or something. And if you see that there are you can form a boundary, you can create that to a separate service. Now this same microservices, modular services which you design, can be designed in a form of a serverless way as well, other than the container. So serverless is very lightweight and more easy to implement than a container service, because in the case of serverless, you are actually not bothering about the server part or the infrastructure part at all. That is the responsibility of the cloud vendor. So they give you just a framework or just a basic service where you can create different functions. It can imagine to be just like a opening something like a new program in Visual Studio, where you can write different functions, where each function would do a different logic for your different task for your application. So imagine if you are having a website simply stored in Amazon S3, which is a hosted service, hosted storage service from Amazon. So it has the provision or ability to store the website as well, like a simple React page or something. Imagine your web application goes to next level, where a user can upload something from the website. They may be uploading a kind of a large image or something. Now, later when your website evolves, client wants that images to be displayed on the client machine. So he may have different devices. So your device may be your website may be responsive, and it will be displayed to different devices in a quite effective way. But the images that you stored, you need to display to each device in a different way. You need to display that in a different resolution, better suited for that particular device. So in that case, whenever you are storing the image, whenever a user is uploading the image, you should think about how to best store the image in a separate resolution way. For that to achieve, you can have a AWS Lambda. That is the serverless service which is provided by AWS. There are other serverless service provided by AWS as well, but this AWS Lambda is the basic service, or the most common service that we can see in Amazon. So this service is serverless service works in a way like we can have different bindings. Bindings means when this function should trigger. So in this case of our website, we are storing the website inside an Amazon S3. So whenever there is a new file inside the Amazon S3, we can create a trigger. So we can use that binding, and we can write logic. So we can just focus on the logic, like we can read the image that is uploaded on the storage. Native support is provided by S3 to have binding with the Amazon Lambda serverless function. So we can write the logic, we can reduce the thumbnail, and we can also output the image to different other AWS services like the even the storage itself, or can be to DynamoDB or some other service. So in this way, different services can be integrated with the help of serverless functions, and it's more lightweight because we not need to bother about the associated dependency or anything. Many times many of the cases, these serverless services will provide you the provision to include the packages and all. For example, if you are a C# developer or a Node.js developer, you can add the different packages that are required for the functionality, and you can just focus on the functionality there. So the package can be added using the package management system like the NPM or the NuGet package manager that is provided along with the serverless service. Similarly, if you are confident with the JavaScript, you can write in JavaScript as well. So this way you can focus on the actual logic, and rest of the things like the infrastructure and everything that will be created and spinned up automatically by the associated cloud vendor. So also there are times when you want your application to scale up. So your processing needs to scale up. In this case of the example which we just discussed, sometimes we need to improve the thumbnail conversion time and all. So what we can do is we can configure the serverless function in such a way that it will automatically spin up different instances automatically behind the scene, so that it can handle more workload. So this way, microservices can be developed using the serverless concept as well. So that is up to the developer. So serverless is the trending word that which we could see these days. So different kinds of serverless services can be used, and Amazon Lambda can be used for different purpose. Like the one example is what we discussed. Like we can integrate the different services in a microservices, and we can add logic to different Lambda functions, and these can work parallel together. So there is no need for deploying each services to a different container service and deploy accordingly and scale instantly. Rather, you can have different functions inside AWS Lambda, and it can provide different integrations with each other service, and that way also you can develop a microservice architecture. So the front end or the client portion of the your application will be ideally a website, and behind the scene these different services, either in the form of a container service or in the form of a serverless services, will be working. Not just this, there are different other use cases as well, like the stream processing, where you can have the different social media streams. Sometimes if you want to think about, okay, when I launch my product, what is happening in different social media. So there may be different social media like the Facebook, Twitter, and other opinion sites and all. So we need to collect the data from these different areas. So these different areas are called the different streams. So we need to collect all the data, and to collect and analysis in these data in real time, Amazon offers a service called the Amazon Kinesis. If you look into the documentation of Amazon Kinesis, you can understand how different media streams can be loaded into the Kinesis, and it can provide an analysis based on how you configure that service. So if you want to find out how much what your users are actually telling, or is it a positive review about a product or something like that, you can use this Amazon Kinesis to analyze the social media stream. If you go and look into each different service, each different social media, and try to analyze this, it will be much difficult, because these are all happening in real time. If you look at a particular product under, you can see a lot of comments at a particular point of time, and that may be changing. So a real media stream is actually happening there, and we want to analyze the data. So in that times, we need to use some of these services like the Amazon Kinesis, which can handle the stream in real time. And the other advantage is like the Lambda can also, this Azure serverless function sorry, not Azure, the Amazon serverless function like the AWS Lambda can also be used with the Amazon Kinesis. So whenever some particular event that is happening based on what you have configured, based on what that stream of data has arrived, then Lambda gets triggered, and a final outcome of what you want to convey to the users that can be stored inside a Amazon DynamoDB, because Lambda itself provides a kind of a output binding as well. So that way the end user can see from a simple interface like a website hosted in S3 or something, what's happening behind the scene. So there is 3 different services that is working behind the scene, like the Amazon Kinesis, the Amazon AWS Lambda, which is the serverless function, and also the DynamoDB, which is actually finally storing the result of the analysis output. So this way, when some voting is happening for some game or something, or whatever, some reality show or something, you can process in this way and can show accordingly to the user. So that way, the important thing happening is there, this AWS Lambda can be easily configured with the output and input binding. Input in this case is Amazon Kinesis, and output is the DynamoDB. So you don't need to write or think about the infrastructure or anything. You can just create a Lambda function and can write code on what you want to achieve there. And you can finally integrate that as well. Similar way, you can integrate this Lambda, a serverless function, with the IoT applications as well as for mobile backend as well, where whenever a user is using user wants to send something from their application, you can use this Lambda as an API itself, and it can also output that something to some other services like the Amazon notification services, etc. When those who are subscribed to it will get the return of that. So that way you can configure the different microservices architecture. So in the next episode, we will learn more about some of the asynchronous patterns that can be employed with the serverless and the containers mode of it's not serverless and containers. You can use that for serverless or for container application, but basically it's a kind of a microservice architecture where a disconnected pattern like an asynchronous pattern can be integrated. So now you understand, like whenever someone is uploading something to the blob, you can have a trigger and you can process it. But what happens is that service is down. You need to handle that asynchronously. So there are different patterns out there, like the queue pattern, the job observer pattern and all, event streaming pattern and all. That all we will discuss in the next session. So hope you understand a bit about the different architectures, and mostly in this episode you understand about the microservices architecture, where a single large application is divided into more modular services, and each modular can be developed using different languages as your team like, and these will communicate through an REST API, and these would run independently. But to deploy that, you can have different strategies. But these strategies should be considered at the time of design of the application itself, because based on that is how you develop your application. For if you are planning for a serverless mode of deployment, you think in terms of function as a service, while if you think about deploying it as a container based service, more natively you would think as a different kind of a project based approach. So similar way, you consider that at the time of the design of the application itself. And serverless is the most recent form of approach, and it is more trending nowadays. So if you look at the different applications out there, and if you understand the architecture, most of them nowadays use the serverless services. So AWS AWS provides different services like the AWS Lambda. So this is AWS Lambda is the one that which we discussed now. This is an event-driven pay-as-you-go compute service that lets you run code without provisioning or managing servers. And also AWS Fargate is there. So Fargate is a serverless compute engine that works with Amazon Elastic Container Service and Amazon Kubernetes Service. So different versions are provided there to suit the best needs for the customers. Also, this Lambda can integrate with other different services. Next episode, we will think about the different patterns like the job observer, queue pattern and all, where we want one service to communicate with other service, but not in a real time, in a kind of an asynchronous fashion. Asynchronous fashion means if you have a card service in place and you have a payment service in place. So suppose a customer is actually paying something through the payment service, and if the payment service is down, what happens if you do not employ some pattern there like the queue pattern or something? Usually it results in a failure and the customer have to restart it again. So to avoid that, we ideally store the payment details in a queue and then let the payment service to process it from the queue. So similar way, different patterns are there. To support those kinds of patterns, Amazon or the cloud providers come up with different kinds of services like some of them I will quickly go through here. One is the Amazon SQS service, which is a simple queue service. It is a kind of a messaging queue service enabling you to decouple and scale microservices, distributed system and serverless application. So these are all related terms. Basically here involves splitting up of a main application into microservices. So there are distributed systems and serverless application, and it's have its own different differentiations there, but ideally the concept is almost same, where a more monolithic application is broken down into multiple parts. Then the enhancement of this AWS Lambda called the AWS step functions. One quick thing want to convey with regard to the serverless AWS Lambda function is the Lambda function or the logic you are writing inside the Lambda function must be run in a quick fashion within a certain period of time. It should not be a long running process. So what happens is sometimes you need to run a series of events in a proper way, and maybe one Lambda function is not suitable. So in that case, you can use AWS step functions, which is actually a kind of an orchestrator, which allows you to sequence multiple AWS services into business critical applications. So it's kind of a workflow orchestrator. Similar way, there is an service called Amazon Event Bridge. This is a kind of a serverless event bus that lets you event-driven application at scale across AWS and existing systems. So ideally you communicate with that event bridge, and all the different other services that are subscribed to that event gets a notification, and based on that it will work. Similarly, lot of different services are there. Even this, the initial service which they have started, Amazon started AWS S3, which is an object storage designed to store and protect any amount of data. So when Amazon started that particular service, clients began to use that, and it becomes a massive hit because they can scale the storage in a reliable way, provides a high availability, and it is much cheaper as well. So the next question that comes to them is how to manipulate the data that is stored inside Amazon S3. So they have the data in place, how they want to manipulate the data, or manipulation in the sense like if we store an image, we want to do some alterations or something. So in those days, developers need to write some worker service or something which will pull the data from the S3 and then do the rest of the work, and then again it stores the processed data in Amazon S3. So these days, because of Amazon Lambda is in place and because of its integration with S3, you can simply create events based on what it is stored in the S3, and behind the scene automatically a Lambda can be spinned up. So you just need to configure it. And this binding is very important, and because this binding helps developers, Amazon integrates this binding, this kind of input and output binding with Lambda to different other functions. So it's a kind of a series of kind of a building blocks working together. So you can use different set of services from cloud. You can wrap it and you can assemble it and you can connect it, and then you can build in a way like these different services work consistently and cooperatively in a systematic way to achieve the required behavior of the application. Similarly, there is a database that is offered by Amazon called the Amazon DynamoDB, which is also a serverless, which is also based on serverless. Then Amazon Aurora is also a serverless DB, which is a MySQL and PostgreSQL compatible cases. So lot of applications can be developed using the serverless concepts, and this is a trending word out there. So if you search, you can understand about this. So with this, we can wind up this episode, and on the next episode, we will be thinking about some of the asynchronous pattern that can help to improve your serverless or the microservice architecture or even the container architecture also. So once again, I want to reiterate that actually microservice is what basically fits into this container and serverless mode of deployment. So both are different terms that are much connected with the microservice mode of architecture. Also, the next set of patterns that we are going to discuss in the next episode can be used not only for the microservice architecture or for the container or serverless, but also can be used for the layered architecture as well. If you are developing a simple application and want to not bother with anything, you ideally need to think whether that can be made as a serverless, considering the different cost budgets and everything. So if everything falls within what you expect, then you can go for serverless, because that is the best approach. If that not suited, then you can choose some other approaches like the container approach or some form of approaches like the layered approach, or in some cases a single application may be served to different customers. So in that case, you need to go for a kind of an approach like the multi-tenant approach. But keep in mind that before considering the multi-tenant approach, you need to think whether how much customization is required for the client. If they want to have a lot of customization, then having this containerization of having this multi-tenant application may not be a best fit in that case, because it uses a common structure for different customers. There's a limit to which you can customize that kind of application because it affects other customers. Service-oriented architecture is the one that we could see in the olden days, but nowadays, because of the support for the cloud and the microservices architecture, I would prefer to go with the kind of a serverless kind of architecture, provided if the cost and everything is within the budget. So properly architected serverless kind of application will be much cost effective and which will be much scalable as well, rather than a service oriented architecture. Because if you want to deploy a service oriented architecture, you need to think about creating them as services. You need to think about deploying them as a container application or something, and all those things. But serverless is much easier. Only problem here there in the case of serverless is a vendor lock-in that can happen. So you are tightly binded to a particular technology like the AWS Lambda or Azure function. Whereas in container, you can have the liberty to go kind of a vendor neutral way. So with all these, we can wind up the episode. Thank you very much for listening this episode. Have a great day ahead.